Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Whenever we do these kind of questions, it's always best to convert the pattern into numbers. So we're just going to count the dots. So we've got 2, 4, 6, 8, 9 in the first one. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So our sequence is going 9, 13, 17. And we're going to see what it's going up in. So we're adding 4 each time. And that means our sequence will involve 4n. And then what we do is we go backwards 1 to find the 0th term. So we're going to take away 1. So 9 take away 1 is 5. So the 0th term is 5. And the 0th term just tells us what to add on to the 4n. So 4n plus 5 will be our answer. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down. So it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69, and the reason for that is angles in a triangle equal 180 degrees, and when you do that you get the answer of 42 degrees. So the answer is 42 degrees. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chelton, which is a C. Then we go to Bolko, that's where we're going, and we go through Devley on the way, so we'll do D there. Distance from Chelton to Devley is 34 miles. Distance from Devley to Bovlo is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chelton at 9 o'clock. He drives from Chelton to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes, or 0.75 hours, and the entire distance is 34 plus 16, so that would be 50 miles. Okay. Now, having a look at this, we need to find out what time David was at Devley. So we're going to use our speed, distance, time triangle. So speed equals distance over time. And we're covering up the time, because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it would be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. The formula for an exterior angle for a regular polygon is 360 divided by the amount of sides. Now here we're given the fact that the exterior angle is 30. And we're looking for n, so we just need to rearrange the equation. We can times both sides by n. And then divide both sides by 30. And so we've got n equals 360 divided by 30. And when you do 360 divided by 30, we get the answer of 12. So it's a 12-sided shape. So we're given 21:4 is the ratio. We're just going to have our lines in, because what we need to do is make the left-hand side be 1. Okay. And to do that, for 21, I need to divide it by itself, divide it by 21, and we're going to do the same to the right-hand side. So 21 divided by 21 is 1. Perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. When something gets to the power of 4, you times it by itself 4 times. So we're going to do that to the x cubed here. So we've got x cubed times x cubed times x cubed times x cubed. Now when two powers of the same base are multiplied together, you add the powers together. So here we can add the 3, the 3, the 3, and the 3. And that will give us x to the power of 12. Now there is a simple rule here that we can use. Whenever you've got a power on the inside of a bracket and a power on the outside of the bracket, all you need to do is multiply them together. 3 times 4, which is 12. To work out the area of this prism, we need to first of all work out the area of the cross section, which is this part here, so this triangle here. So to do that, I'm going to do half times base times height. So it's going to be half times the base, which is 22, times the height, which is 14. That gives us 154. So the volume is the area of the cross section times the length. So the area of the cross section we've just found out is 154, and the length is basically how 3D the shape is. So that's going to be 15. So the answer is 2,310 centimeters cubed. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon, and this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. We're going to start by drawing a table of values. We draw the table of values because we've got a curve here, and with a curve you need quite a lot of coordinates to make sure you get the curve right. Now ideally I'd go up in halves, but so that I'm not just sitting here writing numbers, I'm going to go up in ones on this one. I'm going to leave a space there though, and we'll see why in a second. So what I'm going to do is type these into a calculator. I'm going to type in 0.5 times brackets -2 close brackets cubed plus 8 into the calculator, and that gives me the answer of 4. I do the same with -1, that gives me 7.5. 0 gives me 8. 1 gives me 8.5. 2 will give me 12. 3 will give me 21.5. The reason I've left a space there is this axis doesn't go up to 21.5. So what I'm going to do is just do 2.5 to see if it goes up to that, and that should be 15.8125. So that's actually quite useful because that shows that it's not quite 16. So we were aiming for roughly where 16 is. So next thing we do is plot these coordinates. So 2 would be at 4, -1 is 7.5, which we can't be perfectly accurate for, but it's roughly there. Then 0 is 8, then 1 is 8.5, roughly there. 2 is 12, and then 2.5 is just below that 16. So it's almost at 16. Then the next thing we do is just join it up with a nice smooth curve. It's sometimes helpful if you turn your paper sideways. Obviously I can't do it when I'm on this computer, but you want to just keep drawing and don't lift your pen off at all. Just go with the points. And you want to avoid things like feathering, which is like that. We do that kind of thing, and you kind of want to avoid, or you want to make sure you go through the coordinates, and you just make it a nice smooth curve. The exam is very forgiving when it comes to curves. They know that not everyone's got the steadiest of hands, so as long as yours goes through the points and doesn't have like gaps in it or feathering or anything like that, and it's just one continuous smooth line, then you'll get the marks. To find the resultant vector, we just get the two vectors and we add the tops and add the bottoms. And it's a plus -13, so it's 9 take away 13. When we do that, we get 13 at the top and -4 at the bottom. So we're going to first of all draw a tree diagram for this information. You don't have to, but it is easier to understand what's going on. And so the first choice will be the first pick. It'll either be male or female. And the second choice will be the same, male and female. And looking at the questions, there are 3 male names in the hat and 5 names in total. So the fractions for the first one will be 3/5. If there's 3 male names, there'll be 2 females. Now, if we've picked a male name already, there'll be 2 left and 4 left in total. If we haven't picked a female, there's still 2 females, but there's 4 left in total. If we picked a female, there'd still be 3 males and only 4 left in total, but there'd only be 1 female left. 1 female name left and 4 left in total. Okay, we're looking for the probability that the genders of the names are different. So looking at the outcome here would be male-male. That's not what we're interested in. Here would be male-female, we are interested in. Female-male, we are interested in. And female-female, we're not interested in. So we're not interested in these ones. And the way that tree diagrams work is as you go along the tree, any fractions you go across, you multiply together to find the outcome. So this will be 3/5 times 2/4. And I realise I could cancel 2/4, but I generally cancel at the end. So 3 times 2 is 6, 5 times 4 is 20. We're going to do the same with the other root. So 2/5 times 3/4. So 2/5 times 3/4, 3/4. That would be 6/20. Now we're looking to see whether it was male and female or female and male. And the word or in probability means add. So it'd be 6/20 plus 6/20. And this is the probability of different. Which will be 12/20. Now 12/20 will cancel to 3/5 or 3/5. Here we have a quadrilateral, and all of the corners or vertices of the quadrilateral are on the circumference of the circle. So this makes this a cyclic quadrilateral. And something we know about cyclic quadrilateral is that the opposite angles are not the same, but they add up to 180. So to find x, we do 180 minus 45, and that will give us 135 degrees. And the reason we state is that opposite angles in a cyclic quadrilateral add up to 180. To find the interquartile range from a cumulative frequency graph, you first of all see what the graph goes up to. Here you can see it goes up to 20. And what we do is we halve that, and that's the value we use to find the median. So we halve that again, and that's the value we find for the lower quartile, which will be 5. Then you add the 5 to the 10, so the number we use for the lower quartile to the number we use for the median, and we get 15. So those are the 2 points there that we'll find our quartiles. So we draw a line across to find our lower quartile, a line across and down, and I think that is roughly, I think 22 roughly. We do the same again for our upper quartile, line across and down, and that's roughly, I mean these are going up in 4s, so maybe 37, because this line here would be 36, that would be 37. So to find the interquartile range, it is interquartile range, let's do the formula, is the upper quartile take away the lower quartile. Upper quartile is 37. Lower quartile we said is 22. And so 37 take away 22 is going to be 15. Now if you've got slightly different values, that's absolutely fine. The exam will always give a bit of leeway, especially when reading off graphs. So we're told that the two cuboids are similar, which means we can have scale factor, and we can work out the linear scale factor straight away to find out what we times the 14 by to get to the 49. We're going to do 49 divided by 14, big one divided by small one, and that gives us 14, does it? No, 3.5. Okay, so we times it by 3.5. So 14 times 3.5 is 49. But that is the linear scale factor. And this question is all about volumes. So we're looking at going from here to the volume of the smaller one. Okay. So whenever we go from the bigger to the smaller, we're going to divide by the scale factor. So we know we've got to find the scale factor and divide by it. But the volume scale factor is going to equal the linear scale factor cubed, because volume scale factor has 3 dimensions. Volume has 3 dimensions, therefore it's going to do the linear scale factor 3 times in a row, times 3.5, times 3.5, times 3.5, or 3.5 cubed. So the volume scale factor, we're just going to cube that 3.5, and we get 42.875. So it'd be 42.875. And so on our calculator, we're going to do 4,201.75 divided by the 42.875, and we get the answer 98. We're going to start by creating a table of frequencies from this histogram. And so we are going to need our times, first of all, then our frequencies, and then we can add a midpoint and an fx column as well, which we'll need for later. So our times, then our frequencies, then our midpoints, then we'll do the fx later on. Right, so the first group is 0 to 10. And to find the frequency, well, I might as well just show this. So the frequency density is proportional to the frequency over class width. The class width here is 10, and the frequency density is 1.2, so 10 times 1.2 will be 12. And then the next group is up to 30, so we're doing 20 times 3.2, which will be 64. And then the final one will be 30 to 50. So again, we're doing 20 times 0.8, which will be 16. Okay, so we've got our table from the histogram, and we're asked to find the mean. So hence us doing the midpoint, etc. So the midpoint is 5, 20, and 40. And then the fx, we just times these together, and that would be 60, 1,280. And 640. Now, something I said earlier is that the frequency density is proportional to the frequency divided by class width. It does tell us there are 92 people, and if you do the sum of the frequencies, you do get 92. So we know that it's a one-to-one relationship. Okay, so let's do the sum of the fx by adding up these numbers here, and you get 1,980. So to find the mean, we do the sum of fx over the frequency, sum of the frequencies, and that will give us 21.521, blah blah blah, and 2 decimal places, which is what the question asks for, it's 21.52. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top, then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4, and the height is 5. And the radius for the larger cone is 20, and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's a third times pi times 20 squared times 25, which is going to be 10,471.975, blah, blah, blah. We're going to work out the volume for A, and this time it will be a third times pi times the radius now is 4, and the height is 5. So that will be 83.775, blah, blah, blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah, blah, blah. And to 2 decimal places, it's going to be 10,388.20. So the first thing we need to realise is that we can create a right angle triangle from within this cone. So if I draw a line from the top going downwards, a line to the right and a line up, and we can label the sides. So we've got 30 here, and we've got 10 at the bottom here, and we're looking for this angle here, which we're going to call y. And if I just highlight all of this and move it across, then we're obviously going to be using trigonometry to find out what y is. So first step with trigonometry is, well, find out where the right angle is, which is there. And the one opposite the right angle is the hypotenuse. The one opposite the marked angle is the opposite. And the one between the right angle and the marked angle is the adjacent. In this question, we're not using the hypotenuse because there's no letter or number next to it. And so I'm going to do my SOHCAHTOA, SOHCAHTOA. And we're not using the H, so we're going to cross out these two. We're using the TOA, and that stands for tan the angle, which in this case is y, equals the opposite, which is 10, over the adjacent, which is 30. And so tan, so we're going to inverse tan both sides, so we're going to have to solve this. So let's get my lines in. And we're going to inverse tan both sides. So that will just leave y on the left hand side, and then we need to find out what the inverse tan of a third is. And the inverse tan of a third is 18.434, blah, blah, blah. Now, what I did at the start was I moved the diagram away from the cone. Let's just move it back and we'll see the fact that y is exactly half of x, because we've done a line straight down the middle. So to find out what x is, all we need to do is double y. So x is going to be 2 times y. So that's going to be 2 times the 18.434, blah, 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 blah. And so that is going to be 36.869, etc. And it says it wants it to correct 2 decimal places, so that's going to be 36.87 degrees. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.